Welcome to PhET. This video primer will give you an introduction to the simulation features and uses. This overview is intended for teacher viewing only. Sims are designed to be exploratory tools, and showing this to students can interfere with their exploration of the simulation.
The graphing line simulation allows students to investigate relationships between linear equations, graphs of lines, and slope. On the first three screens, students interact with equations or line graphs to investigate slope, the slope-intercept equation, or the point-slope equation. On the fourth screen, students play a game to test their understanding of slope, linear equations, and line graphs. Let's take a look at the slope screen to start. The screen contains an interactive line graph and an interactive slope equation. Students can change the slope of the line either by dragging a point on the graph or by changing the numbers in the equation, and the corresponding representation updates dynamically. In my classroom, I challenge students to determine the slope of the line using 2 additional points. Students can use the point tools to help identify these points. Once they've made their predictions, I have students check their work using the simulation. We then have a class discussion to reinforce that the slope of a line can be calculated using any 2 points on the line. Students might find the slope tool helpful when completing this challenge, as it displays the rise and the run of the line on the graph, or they can uncheck the slope tool to hide these values. Let's move on to the slope-intercept screen using the navigation bar. The screen again includes an interactive line graph, but this time the interactive equation shows the slope-intercept form of a linear equation. Note that the colors of the points used to change the y-intercept and slope of the line map to the corresponding values in the interactive equation. Students have additional tools to use on this screen, including the ability to display the parent function or the negative of the parent function. I like to have students compare the parent function with lines that have slopes of less than 1 or lines that have slopes of greater than 1. Let's turn off the parent function for now. I also challenge my students to compare the slopes of perpendicular lines and parallel lines. Students can use the Save Line button to generate a series of lines to compare. The equation of the line is shown directly on the screen, allowing students to compare the slopes of these lines. It's important to note that the equation for the line displayed on the graph is always simplified, but the interactive equation reflects the location of the 2 points displayed on the graph and might not be simplified. Students can generate a line with an undefined slope. When this occurs, a red X appears over the interactive equation to indicate that the equation of the line cannot be represented using slope-intercept form. The same behavior occurs on the slope screen and the point slope screen, which we will explore next. On the point slope screen, students can change the 2 points on the graph, and the interactive equation updates dynamically as in previous screens. Color coding is again used to help students map terms in the interactive equation with points on the graph. In my class, I check student understanding of the point-slope equation by closing the panel with the interactive equation, changing the line graph using the points, and asking students to write an equation to describe this line. I have students check their work using the simulation. Conversely, I could ask my students to predict how the graph of a line would change if I alter the value of the slope or change the point used to generate the equation. To do this, I can save the original line, check Hide Lines, and then change the slope or location of the point on the graph using the equation. After giving students time to make predictions, I can uncheck Hide Lines and have students compare their predictions to the graph. Now let's take a look at the line game to see how students can check their understanding of linear equations and line graphs. The game screen consists of 6 levels, which increase in difficulty. The teacher tips on the PhET website give specific details about the types of challenges included in each level. Let's take a look at the 2 ways students are asked to answer challenge prompts using examples from Level 1. Some challenge prompts provide students with a linear equation, and students interact with the graph to complete the challenge.